Okay, so let's go into algebraic fractions. Firstly, we'll go through addition and subtraction. The process of adding and subtracting algebraic fractions is very similar to the process of adding and subtracting normal fractions. So, if we have something that have two fractions that have the same denominator, then we can simply operate on them. So for example, if we have say 2 over 3 plus 1 over 3. So in this case, since the denominators are equal, we can just add at the top, add the numerators. So 2 plus 1 over 3, which equals to 3 over 3. If the denominators are different, say 2 over 4 minus a quarter, then we have to make the denominators equal by converting the two fractions into two equivalent fractions. So in this particular case, we can see that the multiple of 5 and 4 would be 20. So the process we have to go through is to turn the both denominators into 20. So we multiply by 4 here, we multiply by 5 here. And notice that we have to convert it into equivalent fractions. So whatever we do to denominator, we have to do to the numerator. So we multiply the top as well. In the end, we have 8 minus 5 over 20, and we end up with 3 over 20. Now, the process is exactly same if we have algebra involved in it. So for example, if we have, say, 2x over 5 minus 3x over 5. So we can just operate on the numerators and leave the denominator the same. 2x minus 3x. So we have minus x over 5. However, sometimes, well, actually, it's the same if the pronumeral is in the denominator as well. So for example, 2 divided by x plus 7 over x. Since the denominators are equal, we can just operate the numerators, sorry, which would be 9 over x. Okay, if the denominators are different, then we'll have to turn them into equivalent fractions again. So for example, if we have x over 3 plus x over 2. So in this particular case, we have to convert the denominators. And the lowest common multiplier of 3 and 2 is 6. So we multiply by 2 here, we multiply by 3 here. And remember, whatever you do to the denominator, you have to do to the numerator. So multiply by 2 here, multiply by 3 here. So we have 2x plus 3x over 6, which gives us 5x over 6. So it works the same for subtraction as well. Say, let's say 4a over 5 minus a over 3. So in this case, we have to find the lowest common multiple of 5 and 3. In this case, it's 15, so we have to make the denominators just 15. Whatever we do to the denominators, we have to do to the numerators. Once again. So, 3, 4a, that gives us 12a, and minus 5a. over 15, which gives us 7a over 15. Now, it's exactly the same process if there are pronumerals in the denominator. So let's say if we have 9 over x plus 2 over 3x. So in this case, we have to make the denominators the same. So the lowest common multiple of x and 3x is in fact 3x. So we just have to multiply this side by 3 and the numerator by 3 as well. So we end up with 3 times 9 is 27 over 3x plus 2 over 3x. So we have 27 plus 2 over 3x, which gives us 29 over 3x. However, even if the denominators are made of different pronumerals, it will still work. So for example, if we have 2 over x minus, say, 3 over y. So obviously, the lowest common multiplier of x and y are, the lowest common multiple of x and y is xy. So we multiply this side by y, we multiply this side by x. And the top, we have to do the same. So we have 2y minus 3x over xy. Of course, we can't operate on it any further because these terms are not the same. So we leave it like this. So let's try another example where we only have one pronumeral. Say 5a minus 2a. So in this particular case, we have to